Welcome back. In this video, we'll be talking about measurement error, validity, and reliability. Measurement error is the bane of researchers and statisticians everywhere, because if our data is poorly measured, then any results are likely to either understate the true associations, which makes it harder for us to find effects even when they do exist, or misstate the associations entirely. And it's doubly true for social scientists that measurement error is a problem, because we often use variables like self-rated health, which are difficult to interpret even for one person and are prone to vary day by day based on other circumstances, as well as between people. Circumstances like your mood, whether you're in pain right now, changes in your job status, and so on. So, what else could cause error in measurement for survey data? Well, it can be introduced by any number of things. Faulty or imprecise instruments, like a survey that has overlapping categories, non-compliant respondents who don't answer or lie, recall limitations where people can't remember something, and survey non-response overall. So for example, we know that people with very high incomes and people in socially undesirable categories are less likely to respond to surveys, which skews our data, causing measurement error, and so on. There are any number of reasons. In fact, we could talk about measurement error for the rest of the course. Penn State actually has a graduate course on measurement, but the basic idea is fairly simple to understand. A measurement model assumes that every item, survey question, or whatever, has what's called a true score for each case. For example, if the question is, how satisfied are you with your life in general these days, my true score might be around mostly satisfied. Measurement error comes in because I might not get that answer every single time you ask the question. Some days I'll be excited that my students are really understanding the central limit theorem, and I'll say I'm really satisfied. Some days I'll be frustrated, but because my kids at home are sick and won't stop fighting with each other, and so I might say I'm only somewhat satisfied. This can happen even if I know that the question is meant to ask about a broader range of times, because my current experience can color my judgment of the past. The problem is like thinking about if Serena Williams has an off day on the tennis court. If we only watched that one day, we might not think she was a world-class athlete. But if we looked at her scores and her placements across many tournaments, we would have no doubt as to her dominance, that is, her true score of how athletic and how good of a tennis player she is. In some cases, errors can also be consistently in the same direction, which presents an even bigger problem. My step-grandmother, for example, immigrated to the US from Brazil around 80 years ago. And when she went through customs and immigration, coming into the country, she lied about her age. She said she was a few years younger. She says it's because the clerk was cute. She claimed to be that young for years and years, until finally she retired, and she tried to apply for Social Security benefits. Unfortunately, she was denied until she could prove her true age, because that error was always in the same direction, and so for years and years she had documents saying that's something that was actually not true. So there are two really important concepts to understand and keep straight about measurement error. The first is validity, the second is reliability. They're related. In fact, reliability is a part of validity, a type of validity, but both are important enough to be overarching concepts that you'll need to know well. Validity refers broadly to how well data measure what it's supposed to represent. So to put it differently, we can trust that there's only minimal error if there's high validity. The problem is that, like true scores, there's not one test you can run and get a little printout that says your measure is 96% valid. But we do have a variety of tests or litmuses to look for possible validity issues. The first is called face validity. Does the item seem like or appear on its face to capture the construct you set out to measure or test? If I want to know how good the Seattle Seahawks are, for example, I wouldn't start studying the Sounders, the soccer team, even though they're both professional sports teams. They play in the same stadium in the same city. The Seahawks' overall salary, their record over the last few seasons, or their rating in the polls would all have face validity as possible measures of their skill. But nothing about the Sounders would tell us about the Seahawks. Criterion validity instead uses an objective outside measure to compare to. If you've seen Moneyball, and and the methods used in that, they're extremely data-driven ways to predict how often a baseball player or another team will win. They do this by analyzing mountains of data on individuals and teams from previous seasons, and they create model criteria of the statistics that are most predictive of wins. Criterion validity, based on how well current values predict future behaviors like that, is called predictive validity. Likewise, if a driver is weaving on the road and gets pulled over, a police officer can test the validity of their suspicion that the driver is impaired by smelling her breath or using a breathalyzer. Because these comparison criteria are evaluated at the same time, it's known as concurrent validity. That is, we have a criteria to compare to at the same time to cross-check that what we're seeing is actually what we think we're seeing. Construct validity can be evaluated like either face or criterion validity, but it's based on whether a measure or a scale of multiple items covers the full range of a concept. If we wanted to measure parental socioeconomic status, for example, you would ideally want to include not only family income, but both parents' education levels and their occupational prestige. Only including one item would probably approximate socioeconomic status fairly well, and it usually does, but it doesn't encompass the entire construct, so it will perform poorly in cases where not all of the items show a similar answer, like if both parents were archaeologists with PhDs and traveled all over but had no savings, no home, no job security. One final very important type of validity is reliability, so important that we treat it as a completely separate category to talk about. Reliability is whether a measure comes up with the same results over time or measured in different ways, unless the true score changes. So the simplest measure of this is test-retest reliability. It goes back to the example of measurement error and life satisfaction I used. I suggested my answers would hover within about one category either way of somewhat satisfied over time. Now I could have the same average and bounce back and forth between more extreme response, extremely satisfied, extremely dissatisfied, and even if I had the same mean value of somewhat satisfied, I would have decreased reliability and thus decreased validity because I couldn't know from one measure to the next what it was going to be. There's a lot of error in any given measurement. The fact that I might actually become more or less generally satisfied over time complicates testing reliability. But there are ways even then, if you have more than two occasions of the same variable, to separate true change from random error variation. Here's another example. Penn State's men's hockey team had poor between-period reliability in their first couple seasons, at least in the games I saw. They would hold to their own with some of the best teams in the country for 1 or 2 periods, but play poorly in the third. On a longer time scale, though, both their true power and their consistency, that is, their reliability, have increased over time. So not only has their team gotten better, but they've gotten better at playing consistently well and not going back and forth between great and okay. The other kind of reliability you're likely to hear about is scale reliability. It's used a lot in psychology, sometimes in sociology. This is a reliability that instead of how similar something is to itself over time, from one day to the next, scale reliability is all about whether the different items or questions that go into a scale measure that combines multiple items, how well they measure the same construct. Reliability is still only a part of a validity, but in datasets where the same cases are followed over time or with multiple measures of the same concept, it's a very important one to consider. Again, validity is everything about how well the constructs are measured. Reliability is the aspect or the subset of validity that has to do with consistency over time or within a scale. You can rely on it. Keep those two straight first and foremost. After that, try and remember the other types of validity here. Face validity is whether it makes sense. Criterion validity is whether the values are consistent with other measures of the same idea. And construct validity is how measures both fit within and fully represent the overall construct. Within reliability, test-retest reliability is whether you get the same answer over time unless you expect it would actually change for some reason other than error. And scale reliability is how well multiple items that are put together to create one bigger scale, how well they actually measure the same construct. I know that's a mouthful. Thanks for sticking with it. See you soon.